I had a student give me a kind of a doozy of an equation here to solve. So we have two linear equations. Negative y equals 33 sevenths minus 11 sevenths x, and 0 equals negative 5y minus 35 plus 9x. And I've got a couple examples I'm going to do, but here's the first one. And I'm just going to show you kind of my method for doing this. I mean, it's the same method that's used all over the world. I like elimination. That's kind of what I like to do. But the first thing we need to do is get this thing so that everything lines up. So if you notice, everything up here, nothing's lining up. Like the y's aren't together, the x's aren't together. This 35's kind of stuffed in the middle. And so what I like to do is just put everything in what's called standard form. So ax plus by equals c, or move all my variables left, move all my numbers right. And so that's the form I'm going to want to do. And so we'll look at this first equation here. And so the first thing, so I'm just going to off to the side here, solve it, just kind of manipulate it a little bit. So you got negative y equals 33 sevenths minus 11 sevenths x. So the first thing I like to do is get rid of my fractions. I just, they're painful to deal with anyway, so if we can get rid of them, why not? So the first thing I'm going to do to this equation is multiply the whole thing by 7, because that's my common denominator. And so this would be negative 7y equals, well, if you take 7 times 33 and then divide that by 7, you end up with 33. If you're unsure of that, get a calculator out, take 7 times 33, then divide it by 7. You will end up with 33. Same with when you take 7 times negative 11 sevenths. You'd end up with negative 11x. Okay, and so we've got this 7y equals 33 minus 11x, and we want to put it so that we're lined up with everything ax plus by equals c. So I want to move this 11x then to the left across the equation. So I'd add 11x to both sides. And now we've got 11x minus 7y equals 33. Okay, so then we do the same with the bottom equation. And so I'm just going to rewrite it here. 0 equals negative 5y minus 35 plus 9x. And so we want all of our variables on the left, all of our numbers on the right. There's a couple ways you could do this. Just to keep things simple, I'm going to leave it as is. One easy way is just to move the 35 over. So that might be the easiest way. I guess I'm going to go ahead and do that. So if you add 35 across this equal sign, we'd have everything we need. So if I flip that, I would have... so what we do then is we'd add 35 to both sides. So we'd have 35 equals negative 5y plus 9x. And now I'm going to flip that. So negative 5y plus 9x equals 35. So I just flipped it both across the equal sign. That's called the symmetric property. And then I'm going to use the commutative property because I want my x, my x first, then my y, and then my number. And so I'm just going to rearrange the 9x and the 5y. Don't have to change signs because we're on the same side of the equation. But you'd have 9x minus 5y equals 35. So here's my two new equations. So I'm going to put these over the top of each other, and I'm just going to use elimination to solve these. So I'm going to rewrite these and then go from there. So now that I have the equations rearranged, we can go ahead and either eliminate the x or the y. Either one you want to do. And so here we go. Okay, so I'm going to go ahead and just match up my x's, but you could also match up your y's. It doesn't really matter. And so in order to do that, all I'm going to do is make a greatest common multiple here between 11 and 9, or least common multiple. And so I'm going to multiply the 9 by the 11, and the 11 here, I'm going to multiply that or the 9 down here, I'm going to multiply that by negative 11 and distribute through. So if you do that across the top, you'd have 99x minus 63y equals 297. And then if you do it across the second equation, you'd have negative 99x, sorry for that little squiggle at the bottom, plus 55y equals negative 385. Add those two equations together now. The x's would cancel. Negative 63 and positive 55 is negative 8y. And then 297 minus 385 is negative 88. And so y is equal to 11. So with one of those answers, now I'm going to plug that 11 into one of the original equations. So I'll just plug it into the top one. And so you would have, I'll switch colors. So you'd have 11x minus 7 times positive 11 equals 33. So 11x minus 77 equals 33. Move the 77 over. And I must have a sign error. Hold tight. I do not have a sign error, so that's 33 plus 77. And so I'm running out of room here at the bottom. So I'll just stick it up here at the top. So 11x equals 110. And so x is equal to 10. 77 plus 33, 110. And so 10 and 11 are your two values. That's where the two lines cross. And there you go. So there's a kind of a hard example of simultaneous equations. Hope that helps, and see you next time.